Welcome to the MSBTE online learning platform. We bring you the most relevant content in an exciting digital format. Today, we will be studying a very interesting module for applied mathematics, applications of definite integration, which includes topic, area under the curve, and the volume of the solid, where we will be studying some interesting facts about application of definite integration, and we will be practicing some of the examples based on it. So let us begin. Dear students, you learned integrations in last topic. Now we are going to learn the module application of definite integration, and the topic is area bounded by the curve. Objectives: students should apply the knowledge of definite integration to find the area bounded by a single curve. Learning outcomes: students will be able to find area bounded by a single curve. Area bounded by a curve. Y equals to apex always represent a curve. Here, y equals to apex is a curve, then the area bounded by the curve y equals to apex between x equals to a and x equals to b is given by the formula integration a to b y dx. See, here the diagram is, the curve is y equals to apex shown in the diagram, x equals to a is a line parallel to y-axis, x equals to b is a line parallel to y-axis. Then this is the region bounded by the curve y is equals to apex between x equals to a, x equals to b. Then the region is shown by the red color, whose area is to be found out. And this area will be found by the formula integration a to b y dx. Is it clear? So students, let us have some examples. First, we will see very simple example, that is find area under the curve y equals to e raised to x between the ordinates x equal to 0 and x equals to 1. So if you observe in this example, the function is y equal to e raised to x is given. The ordinates means the limits of integrations are given, that is x equal to 0 and x equals to 1. So what to do? Simply putting these values in the formula of area integration a to b y dx. Let us see. This is the formula integration a to b y dx. Putting these values of a, b and y, we get integration 0 to 1 e raised to x dx. Here the integration e raised to x is very simple, whose integration is e raised to x. So putting the integration e raised to x between the limits 0 and 1. Now you have seen the last chapter how to put the limits. First we put upper limit x equals to 1, then lower limit x equal to 0. We get the step area equals to e raised to 1 minus e raised to 0. Can you guess what is the answer? Yes, right. Because e raised to 0 is 1, hence the area is e minus 1 square units. Understood? So the answer is e minus 1 square units. It was very simple example. So I hope all of you understood this. Is it okay? Let us go to the next example, which is find area under the curve y square equals to 4x bounded by the line x equal to 0, y equal to 0 and x equal to 4 in the first quadrant. Now, while solving the problem, first you understand the problem, means what is given in the problem. In this problem, you are given the equation of curve y square equals to 4x. You should have sufficient knowledge of curve tracing. That is, means from the equation of curve, you should be able to understand geometrical idea of the curve. The parabolas are there whose equations are y square equals to 4x, y square equals to minus 4x, x square equals to 4ay, and x square equal to minus 4ay. These are the standard equation of parabolas. In this case, this is y square equal to 4x, which is symmetric about x-axis. See the diagram. In this diagram, this is a parabola y square equal to 4x whose vertex is origin and symmetric about x-axis. Another is x equals to 4. X equal to 4 is a line parallel to y-axis which is drawn in the diagram, that is x equals to 4. The boundary is y is equal to 0, that is the x-axis. Hence, the region is OAB whose area is to be found out. Understood? In this case, x equal to 0 is y-axis, y equal to 0 is x-axis, x equals to 4, a line parallel to y-axis, and y square equals to 4x is parabola. Hence, the region is bounded by these 4 curves, which is shown by red color. Now, the next part is how to decide the limits of integration. In this case, you are going to measure area from point O, where it is x equal to 0 because it is the origin, to the point A, which is x equals to 4. So, what is the limit of integration? Right, 0 to 4. You got the limits. You are given the equation y equal to 4x. Means you can put these values in the formula integration a to b y dx, which is integration 0 to 4 root 4x dx. Is it right? Now root of 4 is 2. That can be taken outside the integration because it is constant. Integration 0 to 4 root x, that is integration 0 to 4 x raised to 1 by 2 dx. Which formula apply here? This is in the power form, that is integration of x raised to n dx equals to x raised to n plus 1 upon n plus 1. Hence, the integration becomes twice x raised to 3 by 2 upon 3 by 2 between the limits 0 and 4. Is it clear? Now what will do? Yes, right. You will put the limits. Which limit will put first? Upper limit, right. Then lower limit. What will do then? You will subtract the value of lower limit from upper limit. Let us see. That is 4 by 3, 4 raised to 3 by 2 minus 0. 4 raised to 3 by 2, that is 2 raised to 2 raised to 3 by 2. 2 is getting cancelled, that is 2 raised to 3 is 8. So what will be answer? That is 8 for the 32 by 3 square units, right? So what is the area under this curve? Is 32 by 3 square units. Understood? In this example, you got the knowledge of curve tracing, that is parabola, y square equals to 4x. Let us go to next example, which is find area under the curve y is equal to sin x and x equal to 0, x equals to pi. This is also a simple example. But what happens here, the function is trigonometric. What is the function? Sin x, whose graph is shown in the diagram. Y equals to sin x represents this graph. X equals to pi is the first point. Origin is x equal to 0. To the point P, x equals to pi. These are the limits of integration. The function y equal to sin x. So you got all the values which you required. Simply putting these values in the formula of integration. Which is the formula of integration to find the area? Right, integration a to b y dx. What is a and b? Right, limits. What are the limits here? Right, 0 and 4. What is the value of y here? Yes, right, y is equals to sin x. Putting these values in the formula, we get integration 0 to pi sin x dx. Can you tell me what is the integration of sin x? Right, very good, minus cos x. So next step is minus cos x, right, between the limits 0 and pi. What to do now? Putting the limits. Yes, which limit to put first? Right, x equals to pi. And then, very good, x equals to 0. So we get the step minus into bracket cos of pi minus cos of 0. Remember, you students always commit the mistake when there is a minus sign outside the bracket. This is our experience when we assess the papers in examination. You always forget the minus sign which is outside the bracket. So be careful when there is a minus sign outside the bracket. Can you tell me what is the value of cos of pi? Very good, minus 1. And cos of 0? Plus 1, good. So, putting these values, we get, what will we get? Minus into bracket, minus 1, minus 1. Minus 1 is, right, minus 2. And minus minus becomes plus 2. So students, remember, you always commit the mistake here, minus minus plus. You always forget to make it plus. Hence, you are losing 1 mark in examination, though your answer is correct. Understand? Okay, remember. So what is the area here? The area bounded by this curve y is equal to sin x is, right, twice or 2 square units. Is it clear? Don't bother about the type of function. It may be trigonometric function, it may be algebraic function, it may be any kind of function. Simply apply your knowledge of integration. It is simply revision of integration. What is the additional part you are going to do in this topic? That is, you are sketching the curve and putting the limits in a proper manner. Okay? Let us go to next example. And the example is, find area of circle x square plus y square equals to 25 using integration. Students, this is very good example because there is always a problem of finding area of circle in examination. What is the standard equation of circle? Right, x square plus y square equals to r square. So in examination, the problem may be find the area of circle x square plus y square equals to r square, or maybe r is certain number. In this example, we took r square equals 25. Means what is the r? R is, right, 5. What is x square plus y square equals 25? Yes, very good. It is a standard circle, standard equation of circle. What do you mean by standard equation of circle? Means the center of the circle is at the origin. See the diagram. See this diagram. This is the circle, right? The center is at the origin. That is meaning of standard equation of circle. Okay? What is the equation of circle here? X square plus y square equals to 25. Comparing this with standard equation, x square plus y square equals to r square. What is the radius of the circle? 5, right? Absolutely right. So r is 5. Now, see this. If you observe this diagram carefully, you will find that the circle is divided into 4 equal parts. Okay, how to decide this? See the powers of x and y. The rule says, if the power of x is even, the curve is symmetric about y-axis. If the power of y is even, then it is symmetric about x-axis. In the equation, both the powers of x and y are even numbers. Hence, the curve is symmetric about both axes. Means what? The whole region is divided into 4 equal parts. Means what? Right. We can find the area of 1/4 part, that is called region, which is OAB, shown by red color, right? So what is this region OAB? we can say this is the region bounded by the curve x square plus y square equals 25 between x equal to 0 and what is x? No. What is the radius of circle? Right, 5. So what is OA? Radius of the circle, which is 5. So what is x at point A? Right, absolutely correct. X is 5. So what are the limits of integration? 0 to 5. Right, very good. So how we find the area of the region OAB? Yes, we are putting the values of A, B and Y in the formula x square plus y square is equals to r square. Okay? And then making it 4 times, we get the area of the circle, that is area of circle equals to 4 times area of region OAB, which is using the formula 4 times integration 0 to 5 under root of 25 minus x square dx. Can you guess which formula will you apply to find this integration? No. Yes, you? Right. The formula is integration a to b root a square minus x square dx is equals to x by 2 root a square minus x square plus a square by 2 sine inverse of x by a plus c. Because the function is in the form of root a square minus x square dx, we will apply this formula. Putting these values in the formula, we get area equals to 4 times x by 2 under root of 25 minus x square plus 25 by 2 sine inverse of x by 5 between the limits 0 and 5. What is the next step? Right, putting the limits. We are putting the limits. Which limit will we put first? Right, upper limit x equals to 5. So what do we get? 4 times putting x equals to 5. 5 by 2 under root of 25 minus 25 plus 25 by 2 sine inverse of 5 by 5. Now putting lower limit minus 4 times 0 by 2 root 25 minus 0 plus 25 by 2 sine inverse of 0 by 5. If you apply your present knowledge of mathematics, 25 minus 25 is 0, 5 upon 5 is 1, that is sine inverse of 1. Again it is 0 because x is 0. 0 into anything is 0, so this term becomes 0. Sine inverse of 0 is 0, so this term becomes 0. So the first term 25 minus 25 becomes 0. Third term, that is 0, and fourth term is also 0. So what will you get then? Simply 4 times 0 plus 25 by 2 sine inverse of 1 minus 4 times 0 plus 25 by 2 sine inverse of 0 gives you 4 times 25 by 2 sine inverse of 1 is pi by 2, that is 25 by 2 into pi by 2. 2 into 2 is 4 and 4 is getting cancelled. So answer is right 25 pi square units. So what is the area of the circle here? 25 pi square units. Remember, what will happen in examination? They can change the value of r. Everything remains same. Suppose I can generalize this problem. What will be the problem? The circle will be x square plus y square equals to r square, where r is the radius. You put r equals to 4, r equals to any number, you get new problem. There can be infinite values of r, so you can have infinite number of problems from the same one. So remember one problem, because this type of problem is always asked in examination. It is asked number of times in examination. So if you remember single example, you can find any example. So okay, I hope you understand now. Very good. Let us go to the next example. And the example is find area of loop of curve y square equals to x square 1 minus x. Students, this is a different type of example. You know what is a loop? Right? Loop is a closed curve. What was the curve in the last example? Circle. It is a closed curve. Yes. So it is also loop. So loop is a closed curve. Now, in first three examples, limits of the integrations directly given. In fourth example, we apply the knowledge of circle and we found the limit of integration. In this example, how will you find the limits of integration? So you must know certain rules of curve tracing. The first rule is, if the power of x is even, the curve is symmetric about y-axis. If the power of y is even, symmetric about x-axis. Similarly, if the power of x is even, symmetric about y-axis, I told in last example. If you observe this equation, what is the equation here? Y square equals to x square into bracket 1 minus x, right? So whose power is even here? No. X is not even, because if you simplify this bracket, you will get x square minus x cube, and the cube means the power is 3, which is odd. So we can't say the power of x is even. Power of y is even, so this curve is symmetric about x-axis. Power of x is not even, so this curve is not symmetric about y-axis. So we come to the one point, it is symmetric about x-axis. Second point, the constant term is absent. Constant term is absent, means the curve is passing through origin. So this is a curve here, passing through origin, symmetric about x-axis, right? It is symmetric about x-axis. In examination, in example, you are asked to find area of the loop, means whole loop. In the previous examples, we found the area above x-axis. But in this case, you are asked to find area of the whole loop, and it is symmetric about x-axis, so half region is below x-axis. Can you tell me what we'll do in this case now? Yes, we'll find the area above x-axis and we'll make it double. That will give the area of the whole loop. Before that, how to find the limits of integration? Remember, it's very important, but very simple and easy. How? What you said in the last statement? I told you that it is symmetric about x-axis. Means what does it mean? It is cutting x-axis somewhere. Means what? Right, on x-axis y is 0. So putting the value of y equal to 0 in the equation of the curve, we get 0 equals to x square 1 minus x. Solving this equation, what do we get? X equal to 0 and x equals to 1. It's very simple. You did it in 9th standard. X square 1 minus x, 0 means what? X square equal to 0, 1 minus x equal to 0, that is x equal to 0 and x equals to 1. It means that if you go back to diagram, you will find the limit is 0 to 1. Now you got the limits, you are given the curve, so what you need now? Nothing. Simply you are going to put this value in our formula. We get, what do we get? See here. Integration 0 to 1 x under root of 1 minus x square dx. And it is twice because we are going to find area of the whole loop, right? So we will making it double. Can you find a difficulty here? Anybody can guess? Anybody can find difficulty to evaluate this integration? Apply your knowledge of last topic. No one? See. You can find the integration of root x. But it's very difficult to find the integration of root 1 minus x. Why? There are two terms under the root. If it is root x, we can do it easily. So how to convert these two terms into single term? If you remember, in last article, you have a property of definite integration. What is that property? Let us see. The property is integration 0 to a fx dx is equals to integration 0 to a f of a minus x dx. What to do in this case? What to do in this case? Right. Simply replacing x by a minus x. In this case, what is a? A is absolutely correct. A is 1. So, applying this property, what will you get? Replacing x by 1 minus x, 1 minus x, simplifying 1 minus 1 minus minus plus x. Remember, again minus minus plus x. You always forget this and losing the marks in examination. So, remember. So, what will be it? It will be simple 1 minus x into root x dx. What was our aim? Our aim was to get a single term under the root. So we got a single term under the root. How did you get it? Right, simply applying the property, we got it. What is the aim behind it? Now, it is very simple and easy to simplify. We can multiply the bracket 1 minus x by root x. So what do we get? 1 minus x multiplied by x raised to half, that is 1 into x raised to half is x raised to 1 by 2. X into x raised to half, that is x raised to 3 by 2. How? It's very simple. Go to 6th standard. A raised to m into a raised to n is equals to a raised to m plus n. Here m is 1, n is half. 1 plus half is 3 by 2. Hence we get x is 3 by 2. In this way, the function, or it can be called integrand, 1 minus x into root x is simplified in power formula. Now we can apply the power formula, that is integration of x raised to n is what? X raised to n plus 1 upon n plus 1. That is adding the power by 1 and dividing by new power. That is the integration of power formula. Right? Don't remember x raised to n equals to x raised to n plus 1 upon n plus 1. Simply remember adding the power by 1 and dividing by new power. So what do we get? We get 1 by 2 plus 1 is 3 by 2, dividing by new power 3 by 2. 3 by 2 plus 1 is 5 by 2, dividing by new power 5 by 2, right? Between the limits 0 and 1. That is denominator is 3 by 2 and 5 by 2, that is 2 by 3, 2 by 3. You can take 2 common and 2 to the 4, that is 4 is common outside the bracket, and we will get 4 into bracket, putting x equals to 1, 1 raised to any number is always 1, right? So we get 1 by 3 minus 1 by 5, lower limit is 0, so both the terms become 0, hence we get 4 into bracket 1 by 3 minus 1 by 5, lower limit is 0. And I hope that you can find 1 by 3 minus 1 by 5. How you will find it? By taking the LCM. So students, what is our experience? Many students fail to find 1 by 3 minus 1 by 5. Simply apply the knowledge of secondary school and get it. So what will you get? LCM is 15, and that is 5 ones are 5 minus 3 ones are 3, 5 minus this 2. That is 4 into by 15. What will be it? Right, 8 by 15 square units. What is the area here? Area of the loop is 8 by 15 square units. Understood? So remember, if there is an example of a loop, how to find it? Understand? Okay, you can do 1 or 2 examples of loop at home simply by changing the equation. Recap with objectives. Students should apply the knowledge of definite integration to find the area bounded by a single curve. Conclusion. We have applied the knowledge of definite integration to find area bounded by a single curve. So students, do you have any question now?
Yes, I have one question.
Yes.
Find the area enclosed by the curve y is equal to 3x square, x-axis and ordinate x is equal to 0, comma x is equal to 3.
Okay, this is your example.
Yes.
Find area enclosed by the curve y equals 3x cube, x-axis and the ordinate x equal to 0, x equals to 3. If you understood first example, it was similar example. What is here? When you solve example, first you understand the example means what is given in the example. If you observe here, there is a curve y equals to 3x square, that is curve is given. X is 0, x equals to 3. These are the limits of integration. What is the formula? Integration a to b y dx. What is y here? 3x square. Putting the value of y equal to 3x square. Putting the limit 0 to 3. Apply your present knowledge of integration. What is the integration of x square? It is power formula. Increase the power by 1, that is 2 plus 1, 3. Dividing by new power. So it becomes 3x cubed by 3 between the limit 0 to 3. Understood? And you can calculate now value. You satisfied? It's very good.
Okay, thank you.
Welcome. Now you are fully competent to solve the problems of area using integration. So worksheet is given below. Try to solve at your level. Now, solution of worksheet is provided for cross verification. See the solution of the problems. First problem was very simple, which is equivalent to our first problem. Right? Here y is given, x, limit is given 0 and 3. Simply you put in the formula of integration and got the answer. Right? So, if you observe, what is the mistake committed by you in examination? By putting the limits 0 and 3. You should put the upper limit first, that is x equal to 3 properly, calculate it, 3 square is 9, and their lower limit is 0, and subtract the lower limit. So, avoid such mistakes in examinations. Okay? See the next example? Yes. Again, simple example. Y equals to 1 plus x cube plus 2 sin x from 0 to pi. In this case, it is a combination of algebraic and trigonometric function. 1 plus x cube is algebraic function, sin x is trigonometric function, but don't bother about it. You use the proper formula of integration and write the integration as it is. You put the limits x equals to 0 and x equals to pi. There is cos of pi. Right? When you put value of cos of pi, it is minus 1 and minus minus is plus 2. So here you can commit the mistakes. That is minus 1 minus 2 is plus 2. And another mistake, you forget this minus sign. So minus minus becomes plus. So keep this in mind in examination that minus sign become plus, and when is a minus and outside the bracket, then the sign inside the bracket changes. So plus 2 plus 2. What do we get? We get plus 2 plus 2 plus 4. Otherwise, what will you get? You would have got minus 2 minus 2. Understand this? Okay. Now the example is find the area under the curve y equals to x square from x equal to 0 to x equals to with x-axis. The equation y equals to x square is in the form of x square equals to 4ay. Means it is symmetric about y-axis. The line is x equals to 2 parallel to y-axis. Hence, the region is shown by the red color, that is OPQ, whose area is to be found out. Now, The limits are from x equal to 0 to x equals to 2, very simple. Y is given x square. Put this in the formula integration a to b y dx. Apply your knowledge of integration because it is a very simple integration. Simplify it, you get the answer 8 by 3. But here the line is x equals to 2. Be careful, it is x equals to c form, which is parallel to y-axis. Remember this, x equals to 2 parallel to y-axis. When the equation is x equal to c, it is parallel to y-axis. When the equation is x equal to c, it is parallel to y-axis, and y is equal to c, it is parallel to x-axis. So remember it. So area is 8 by 3 square units. So next topic is, our module is application of definite integration, and topic is area bounded by two curves. We have learned some important topics so far, and we hope you had good time learning with us. Browse through our online library for more content on the MSBTE website. Thank you. Stay connected. Happy learning.